In this video, we're going to be filling out our Intro to 3D Shapes foldable, which should be glued at the bottom of page 12, and your volume of three-dimensional shapes foldable, which will be glued onto page 13. So we're first going to go ahead and look at the Intro to 3D Shapes foldable, and for every shape, we want to shade the base. So we will shade the base as we cover each shape. So looking at number 1, this is a rectangular prism. So make sure you label this as rectangular prism. Now, the first thing we want to do is identify our base. Now, remember, on a rectangular prism, your base is always the bottom. So here, this is the base of my rectangular prism. So now we want to know, what is the formula for P? How am I going to find the perimeter of this rectangle? So remember, to find perimeter of a rectangle, it's length plus width plus length plus width. So for instance, here, my length would be 10. Plus my width would be 3. Plus, if this side is 10, this side is also 10. Plus the length of this side, which is also 3. So now we're going to go ahead and open up our calculators and find the solution for this. So opening up our calculators, we're going to open up a calculating window, and we're going to type 10 plus 3 plus 10 plus 3, and we get 26. So here, the solution for my perimeter is 26. Now I have to find big B. Now remember, big B stands for area of our base. So here, my base shape is a rectangle. So I'm going to put a rectangle around B. And the formula for area of a rectangle, if you reference your formula chart, area of a rectangle is base times height. Now, another formula you can use is length times width, which is what I would suggest that you use. Again, this is length times width. So the length of my prism is 10 times the width of my base is 3. And 10 times 3 is 30. Then the height of your prism is the distance between your bases. So you, on a rectangular prism, you have a base on the bottom and then you have a base on the top. So the distance between these, the height of our prism is 4. So let's continue. Let's now go ahead and look at the triangular prism. So this is a triangular prism. And on our triangular prism, there is some missing information. So for this, we're going to make this an isosceles triangle, and we're going to give this slant heights of 8.7. So first things first, we want to find the perimeter of my base on my triangular prism. Now remember, on a triangular prism, your base is the triangles. Your base is the triangle on a triangular prism. So to find the base going, to find the perimeter going around my triangle, to find the perimeter of a triangle, it's side 1. So I'm going to put S1 plus side 2. So I'm going to put S2 plus side 3, which is S3. Then I'm going to substitute my information. I'm going to plug in my numbers. So for side 1, I have 8.7 plus side 2 is also 8.7 plus side 3, which is 7. So now I'm going to plug this in and simplify it. 8.7 plus 8.7 plus 7 is going to give me 24.4. So the perimeter of my triangle is 24.4. The perimeter of my base is 24.4. Now I have to find B, and remember, B stands for area of our base. So since my base shape is a triangle, I'm going to go to my formula chart, and the formula for area of a triangle is area equals 1/2 times base times height. Now, another formula that you can use is base times height divided by 2. So my students tend to like base times height divided by 2 better, so that is what I'm going to stick with. So the base of my triangle is 7. This is the base of my triangle. The base is 7. So 7 times the height of my triangle, not the slant height, the height of our triangle is 8. Now we know this is 8 because this creates our height is 8 because when it creates a 90-degree angle here, you kind of see how it creates this h here for height. So 7 times 8 divided by 2, when you put that in your calculator, you get 28. So here the area of our base is 28. Now, the height of a triangular prism, again, is the distance between your bases. Now, here you have a triangle up front, and remember, you're going to have a triangle in the back. So the distance between our triangles here is 12. So the height of our triangular prism is 12. Next, we're going to go ahead and look at number 3. So for number 3, this shape is a cylinder. Now remember, on a cylinder, your base shape is a circle. So I'm going to highlight the circle. This is my base shape. Now, the radius of my cylinder, if I look at my base shape, I see that this line only goes halfway. Since this line only goes halfway, this lets me know that this is my radius. My radius is 4. If this line went all the way across our circle, it would be the diameter. Now, the height of our cylinder is the distance between our two bases, the distance between these two circles, which is going to be 8. So now in the table, it is only asking me to find the area of our base. So since my base shape is a circle, if I go over to the formula chart, the formula for area of a circle is pi times r squared. So the formula for a circle is pi times r squared. And then I'm going to plug in my numbers. So pi times the radius, which is 4 squared. Now to find the solution, pi times 4 squared gives us 50.26, which we can round to 50.3. Next, let's go ahead and look at number 4. So on number 4, this shape is a cone. Now on a cone, our base shape is the circle. So here's my base shape. Now, in the table, it is asking us to find the area of our base. So since my base shape is a circle, I first want to write the formula for area of a circle. So if I go to area of a circle, again, the formula is pi times r squared. Now, if you look at your base, again, this line only goes halfway, which lets us know that our radius equals 2. So I'm going to plug that into my formula. Pi times 2 squared. Now we're going to plug into our calculators. Pi times 2 squared, and we get 12.6. So the solution for the area of our base is 12.6. Now the height of my cone, again, is from the center of our base to the peak of our cone, which we see here is 3. Next, we're going to go ahead and look at the rectangular pyramid. Now, I know this is a rectangular pyramid because if you look at your base, these sides are not the same. I have a length of 10 and a width of 8. So again, my base shape here is a rectangle. We're going to start off by highlighting it. Now, going back to our table, I'm trying to find big B, which stands for the area of our base. So I'm going to put a rectangle around B. Now, remember, to find the area of a rectangle, we can do this by doing length times width. So the length of my rectangle is 10 times the width of my rectangle is 8. And 10 times 8 is 80. Now, the height of my pyramid is from the center of our base to the peak of our pyramid, which we see is 6. So here the height is 6. Next, let's go ahead and look at our next shape, and this is a sphere. So looking at the sphere, there is no base shape on a sphere. The only thing you need to know on a sphere is the radius. But looking at your sphere currently, we see that this line goes all the way across our sphere, which lets us know that 50 centimeters is the diameter of our sphere. Now, to find the radius, remember we take our diameter and divide by 2. Half of 50, when we divide by 2, we see that our radius is 25. So that was your intro to 3D shapes. And now we're going to go ahead and get into finding volume of 3D shapes. So the first thing we're going to do is find the volume of a rectangular prism. And the first thing that we want to go ahead and do is write the formula for volume of a rectangular prism. So going to your formula chart, when we scroll down to volume of a prism, we see that our formula is V equals B, big B times H. So I'm going to go over to our notes and we're going to write V equals B times H. Now remember, big B stands for the area of my base. Now on this rectangular prism, remember our base shape is either the top or bottom. So my base shape is a rectangle. So I'm going to put a rectangle around B. Now off to the side, I want to find the formula for area of a rectangle. If you go to your formula chart and you go to area of a rectangle, remember it does give you area equals base times height. However, I like to use length times width. So the length of my rectangle is going to be 7.5 times the width of my rectangle, which is 15. So now in your calculator, 7.5 times 15 gives us 112.5. So now that we have found the area of our base, we're going to plug this back into our problem. So we have 112.5 times the height of our rectangle prism here is going to be 7.5. So 112.5 times 7.5. So we're going to plug this into our calculators, 112.5 times 7.5, and we see that the volume of this rectangular prism is 843.75. My unit here is feet, and since we're talking about volume, this is cubed. So again, the volume of this rectangular prism is 843.75 feet cubed. Next, we're going to go ahead and look at the volume of a cone. So it says, given a traffic cone has a base diameter of 12 inches and a height of 28 inches, we want to know what is the closest volume of the cone. So the first thing we need to do is find the formula for volume of a cone, which is volume equals 1/3 times big B times H. So V equals 1/3 times big B times H. Now, on a cone, remember your base shape is a circle. So to find big B, my base is a circle. So I'm going to go off to the side and go back to my formula chart and find the formula for area of a circle, which is pi times r squared. So the formula is pi times r squared. And going back into the problem, I want to see, do they give me the information I need? Do they give me the radius? In the problem, they tell me my diameter is 12. So if my diameter is 12, to find my radius, I have to divide by 2. And 12 divided by 2 is 6. So I'm going to plug this into my problem. So I have pi times 6 squared. So pi times 6 squared gives us 113.097, which we can round to 113.1. So we're going to plug this into our formula. So we have 1/3 times 113.1 times the height of our cone, which is 28. So going back into our formula chart, we're going to press Control Divide, 1 on top, 3 on the bottom, step out, times 113.1 times 28. And when we press enter, we get 1055.6. So the volume of our cone is 1055.6 inches cubed. However, looking at your answer choice, the closest is going to be C, 1055.58 inches cubed. Okay, next we're going to go ahead and take a look at the cylinder. So on the cylinder, it says the cylindrical paint can has dimensions as shown below, which is the closest volume of the paint can in cubic centimeters. So we're going to start off by identifying our base. Now on a cylinder, remember your base shape is a circle. And since I'm finding volume here, I want to go to my formula chart and find the formula for volume of a cylinder, which we see is. So now that we have identified our base shape and we know we're finding the volume of a cylinder, we want to go to our formula chart and go down to the section for volume. And we see here that the formula for volume of a cylinder is V equals big B times H. So volume equals the area of our base times our height. So going to our notes, we're going to go ahead and write down that formula, which is V equals big B times H. Now our base shape is a circle, so I'm going to put a circle around B. And now I'm going to find the area of that circle. And the formula for area of a circle, if we go back to our formula chart, we see it is pi times r squared. So I'm going to write pi times r squared. Now, looking at my cylinder here, I see that they have given me the information for my diameter. I know that this is my diameter because this line goes all the way across my base. So if my diameter is 16.5, again, to find my radius, we will divide by 2. So when I take 16.5 and I divide it by 2, our radius is 8.25. So I'm going to plug this back into my problem. I have pi times 8.25 squared. So plugging that into our calculators, pi times 8.25 squared gives us 213.825, which we can just round and leave to the tens place as 213.8. This is the area of my base. So again, the area of my base is 213.8 times the height of my cylinder, which is 19. So now we're going to type this into our calculators. 213.8 times 19 is going to give us 4,062.2 centimeters cubed. And looking at your answer choices, the closest one is going to be G, 4,062.7 centimeters cubed. So that was finding volume of a cylinder. Okay, next we're going to go ahead and find the volume of a sphere. So here it says if a basketball has a diameter as shown below, which is the closest volume of the ball in cubic inches? So here I'm finding the volume of a basketball. Now remember, a basketball, its three-dimensional shape would be a sphere. So if we go to the formula chart and we go to formula for volume of a sphere, we see here that the formula is V equals 4 over 3 times pi r cubed. Now this cubed right here, this exponent of 3 is very important. This is what's going to determine if you get these questions wrong or right. I've seen some people leave this as an exponent of 2. Again, make sure you're referencing your formula chart and recognizing that, again, this is an exponent of 3. And I will show you how to put this in your calculator in just a second. So going back to your notes, we're going to use that formula, 4 over 3 times pi times r cubed. So looking at our basketball, we see that the diameter is 9.4. So if our diameter is 9.4, to find the radius, remember we divide by 2. So 9.4 divided by 2 gives us 4.7. Our radius is 4.7. So when we plug this into our formula, this is now 4 over 3 times pi times 4.7 cubed. Now we're going to type this into our calculators. And the first thing we're going to do is hit Control Divide, 4 on top, 3 on the bottom, times pi times 4.7 cubed. Now to get cubed, we're going to press the caret top. And the caret top is right below the equal button and right next to the x squared. It is currently highlighted in red if you don't know where the caret top is on your calculator. So now our exponent is 3. So I'm going to type in 3 and press enter. So here, my answer is 434.893, which we can round to 434.9 inches cubed. And the closest volume is going to be B, 434.89 inches cubed. Next, we're going to look at volume of half 3D shapes. So here, this is a hemisphere. So to find the volume of a half sphere, first, we're going to find the volume of the sphere. And remember, the formula for volume of a sphere is 4 over 3 times pi r cubed. So let's go ahead and write that out. 4 over 3 times pi times r cubed. And the only information, again, you need to know for a sphere is the radius. So here on this sphere, we see that this line only goes halfway, so our radius is 13.4. Now we're going to plug this back into our problem. So here, this is 4/3 times pi times 13.4 cubed. So let's go ahead and type this in. So we're going to start off by pressing Control Divide, 4 on top, 3 on the bottom, times pi times 13.4 cubed. So to get the cube, we're going to use that exponent, that caret top, 3, and we get 10,078.7. Now, since this is half of a sphere, our answer we will have to divide by 2. So when we divide by 2, we see that our answer is 5,039.3. So the volume is 5,039.3 inches cubed. Next, we're going to go ahead and look at number 6. So for number 6, it says find the volume of the water tank below. So to find the volume of the water tank, first I noticed that this is a cylinder. And the formula for volume of a cylinder is volume equals big B times H. So volume equals the area of my base times the height. So V equals B times H. Now, on a cylinder, remember your base shape is a circle. So I'm going to put a circle around B. Now, off to the side, I need to find the area of that circle. So I'm going to go up to area, and I see that the formula for area of a circle is pi times r squared. Now, looking at your cylinder, we see that this line only goes halfway, which means that my radius is 4. So pi times 4 squared. So plugging that into our calculator, pi times 4 squared is going to give us 50.2655. We can round this to 50.3. So 50.3 is the area of my base. Now I want to multiply this by the height of my cylinder, which is 12. So 50.3 times 12 is going to give us 603.6. So this is how much water the water tank can hold. But if we're just trying to find the volume of the water in this cylinder, notice how the water is only halfway full. So I'm going to divide this by 2. 603.6 divided by 2 gives us 301.8. So here the volume of the water is 301.8 feet cubed. And that is finding volume of three-dimensional shapes.